Okay, so today I'm going to work through an example of evaluating a line integral. The question we have is, evaluate the integral over c of the function 2x plus x squared y ds. C is the upper half of the unit circle. Okay, so the first step I want to do in evaluating any line integral is to draw a picture of the curve c. So here's my little picture of the curve c. It's just the upper half of the unit circle. The next step is to parameterize c, which means I want to find an equation for my curve c in terms of one variable. I'm going to call this variable t. So I need to write x of t and y of t to figure out what my x and y coordinates are given its value of t. Well, I'm just going to use the standard parametric equations for the unit circle, which is x equals cosine of t and y equals sine of t. Now, I need to find the bounds for t. I want to figure out what I'm tracing out. In this case, I'm not tracing out the whole unit circle, just the upper half. That's why it's important to draw a picture. It's because I can clearly see that I need to restrict my bounds on t. Well, I know I'm going to start at 0 because I'm starting at the beginning of tracing everything out. But I'm only going halfway around. So the upper bound for t is pi. That will trace out half of the unit circle. If I went all the way to 2 pi, I'd also trace out the bottom half. But I don't want to do that. Okay, so I've done all of these things, and now it's time to solve my line integral. Basically, I want to plug what I know, x of t and y of t, into this equation and then just evaluate the integral as usual. So I'm going to start by figuring out what the square root term is. So I'll find dx dt and dy dt. Well, let's go back to our equations for t. X of t is cosine of t, so x prime of t is negative sine t. And what about y? Well, y is sine t, so y prime of t is cosine t. Now, I'm going to use those two things and plug them into my square root expression. So I'll get negative sine of t squared plus cosine squared t. Okay, well that negative is just going to go away when we square it. So we're going to get the square root of sine squared t plus cosine squared t. Now our favorite trigonometric identity is this thing equals 1. So now I just end up with the square root of 1, which equals 1. So I'm all good. I am all done. Now let's figure out what else we have going on in this line integral. Well, I probably want to figure out what this part is. So let's start writing everything out that we know. Let's figure out what our bounds are. Well, they're 0 to pi. So I'll plug that in. And now I'm going to plug the equations for x and y into my equation for f. So instead of 2x, I now have 2 cosine of t. And they'll have an x squared becomes cosine squared t. And then that y is just sine of t. So this is nice because now I have f in terms of one variable, not two. So I'll be able to solve this single variable integral. Now let's figure out what this was. Well, that was just 1. So this is all just multiplied by 1. And then we have dt. So I want to solve this integral. I see this second term, and I know I'm going to need to use u substitution. So let's start working on our u substitution. U sub. I want to set u equal to cosine of t, because then du equals negative sine t dt. So dt equals negative du over sine of t, which is great because now when I plug the expression for dt in terms of u into this integral, this sine t will cancel, and I'll just have this cosine terms. And hey, this first term is also a cosine t, which is extra nice. So let's start by writing all this down. Well, now I don't know what my bounds are, so I'm going to leave them blank for a second. And I have 2u plus, well, cosine squared of t is u squared plus u squared plus u squared. Now, this dt expression is going to get plugged in for du, well, negative du over sine of t. And then this sine of t will stay. dt. Well, that went away because we plugged in for dt. So this is nice because now these sine of t's cancel. So this whole thing is just in terms of u. The last thing I want to do is I want to figure out what my bounds are in terms of u. Well, I'll plug in cosine of 0 for the lower bound, which is 1, and I'll plug in cosine of pi, which is negative 1. Well, now I've ended up with an improper integral because this number is greater than this number. So what I do is I'm just going to flip the bounds and make the integral negative. So this thing is equal to negative, flip the bounds from negative 1 to 1. And I'll finish writing the integral inside. So I have 2u plus u squared times negative du. So that's going to become a minus u squared. And this whole thing du. Great. Now I'm just going to start evaluating this integral. So I know the integral of 2u is u squared. And then minus 1/3 u cubed. This whole thing is over negative 1 to 1. And the really important thing you don't want to forget is the negative sign in front of everything. So this is the expression that we want. Now, well, that's equal to, keep that negative sign. Now let's plug in and figure out what we're getting. So the first part, u squared at 1. Well, 1 minus 1/3. You can do this out on your paper and then just follow along to check your work. 1, and then minus u cubed. Well, minus 1/3. Negative 1 cubed is still negative 1. So I'm going to end up with something like this. Let's keep working. Which equals negative 2/3, which equals 2/3. So you should check your work in these steps just to make sure you're doing your basic algebra right, because it wouldn't be very fun if you got the wrong answer because of a silly algebra mistake. So here's the answer to our first line integral example problem.